The next talk will be devoted to the treatment accelerator design studies. As I already mentioned, it's very important that we are working together in very close collaboration with CERN. So, Maurizio, please.
Okay, good morning. Yes, I'm Maurizio Vretenar from CERN, where I am in charge of a study for new technologies for ion therapy. And we have a collaboration since many years with CEIST, and we contribute to the accelerator design studies for CEIST. So basically, I will start from the point where I was in Bern at our last CEIST meeting, showing this one, which is the reference conceptual design of the CEIST facility. So this has been shown already before by Professor Litov. What I want to comment here is that this is a good, we believe, a good blend of innovation and being conservative on the other side, because this accelerator facility has many innovative features, so higher intensity to treat faster and more patients, flexible extractions for new innovative ways of treating the patient, equipped with the opportunity, if needed, to also to produce radioisotopes in parallel with the operation, but at the same time, it is conservative. It is based on the same synchrotron design as CNAO, which is proven, is something that can be built relatively simply. And as on top of that, there are some specific features for the CEIST, so we have particular attention to the environmental strategy, to the power consumption of the facility, and there is the idea of the multi-hub facility, as was already presented by Professor Litov. Okay, so what we have done since September was not too much, because we are wrapping up and disseminating the outcome of the original contract with the European Commission, the so-called DLR contract, that finished last year. We are working now entirely in He3+, so the project has been just introduced by Sandro Rossi, and we continue the collaboration between CERN and He3+ and CEIST on the design of some of the components of the accelerator. We have a major issue, which is personnel, manpower, because we were working with two expert colleagues that were paid by CEIST through the first DLR contract and then via He3+. And then what happened at the end of last year is that one left because he has found a permanent position somewhere else, and the other went to 50%. Has found another position 50. So all of a sudden we have lost 3/4 of the personnel that was working actually for CEIST. And now this is actually an issue, and you will see that in what I will present today, there is a really very little contribution from CEIST. And this personnel was also very useful because they were training, they could train young experts coming from the region. So this is actually an issue that really we have to address, how we can really, if we want to build capacity, we also need expert personnel to support this capacity building. Yes. Okay, very quickly, I want just to show you some results of an analysis that we made of power consumption, because already since years we are very, very careful in designing accelerators that have reduced the power, to try to reduce the need of electricity for a new facility. And now in the last month, this really appeared as a very, very urgent priority. So we have, this is the last study that was paid with the old DLR contract, electricity consumption. So you see that we compare the electricity consumption of different facilities, starting from now, 350 kilowatts overall. We have seen that despite the innovative components of CEIST, which is more powerful, we could, with in some ways, remain in the same level of power consumption. We have seen that even if we go to a superconducting layout, unfortunately, we don't gain much in power consumption, but we have identified technologies where we can really work to reduce and to gain another 20% maybe in power. So it's very tricky, it's a complicated exercise, and there is no magic really way of reducing the power consumption. We will always remain between 300 and 350 kilowatt for this facility. Then we have been working on the design of a dual mode injector producing radioisotopes and injecting into the synchrotron. On this one, we are just starting to work with the help of a doctoral student from Montenegro, who is working with us, and at the moment we are getting some initial results. This is an interesting recent development, is a carbon ion gantry. So Sandro Rossi showed before the problems of the importance of a gantry for carbon. To have a small and of reasonable size gantry for carbon, you have to use superconductivity. And this is a scheme using superconducting magnets that is being developed now by a collaboration outside of CEAST, so between INFN, CNAO, CERN, and MedAustron, and then as a small component by He3+, that has a small component by CEAST. So this is a very interesting, very important, I would say, an essential feature for any future ion therapy facility, including for CEAST. It's a pity that really the contribution of CEAST is really minimum into this design, because also at the end the intellectual property of this design really will be somewhere else, and CEAST cannot claim to more than a little fraction of the international property of this design. But you see, it's very promising. You see the size of the machine as compared to the patient. Okay, so for the synchrotron design, we have this is what is being done by the 50% person who still works for CEAST. So this is where we have some progress in the design of components for the synchrotron, in particular injection and extraction from the synchrotron. And we are also analyzing a superconducting option. You see the difference in size at the same scale between a normal conducting and the superconducting. The point about the superconducting design is that this could be an option in case the time for setting up, organizing the construction of CEAST takes longer than foreseen. So this is what you see behind me is the original, the old planning that was done for at the time of the submission of the S3 proposal in 2020. Yes, 2019, 2020, and at a certain moment you see a milestone that was selection of technology that was foreseen in selection of technology, I think, 2023. Now all this has been shifted in the future by probably a couple of years, and the point about considering a small, very compact superconducting version of the synchrotron is that at a certain moment, so is that now in He3+, we are starting the design of superconducting magnets. Basically, a development that is done by INFN in Italy, and in 3 years from now, we will have the first prototypes of superconducting magnets. If this development is successful, then application of superconductivity to an ion therapy machine could be considered for projects like CEAST. This is also something that I wanted to show you because it's a discussion that I know is going on between CEAST Steering Committee and the CEAST Association. This was already mentioned by Professor Litto, the fact that for accelerator projects, we usually start from a conceptual design report, and basically a conceptual design of the facility, of the CEAST facility, is already there, is what I have shown before. Then the next step will be a technical definition to come to a technical design report that usually is used for approval. And in this stage, CEAST really has to go deeply into a technical definition of the project from the conceptual design report that has been already defined to be ready to prepare for a construction. Okay, so this slide is very technical, but I wanted to pass you also some message on possible European projects to support CEAST. It's also making reference to recent discussions with the European Commission about possible ways of supporting CEAST in the next years. Basically, there are 2 types of European projects that can be used to support a project like CEAST. There are research and innovation actions, like He3+, that was mentioned before, that is already ongoing, and there are coordination and support actions. So recently, we have applied, as CERN, we have helped in the submission of 2 coordination and support actions. One was Ion to app for production of initial production, for the initial stage of beam production for this kind of facility, together with Bosnia and Herzegovina. This submission was not successful. There was too much competition, was a special call for support to Western Balkans, and it was not successful, despite the high quality of the proposal, I would say. Now we have tried again another submission, Stronger for Cancer, that is a coordination and support action, this time with Greece, and with looking at option for producing radioisotopes in parallel with cancer treatment. This is now under evaluation. It's been submitted in January. The result should be known in June. But again, I know it is a very competitive call. I'm not very optimistic, and somehow. But again, also the content of this proposal was very good, and if it is not going to be successful, we have to find a way together how we can really keep this work going, even without this project. But all this is very difficult. The calls are very competitive, and our project is very multidisciplinary. So what is very nice is that what we are doing is between physics, biology, and medicine. The problem is that we don't fit neither in biology, neither in physics, neither in medicine. And so always projects that are more focused on the different disciplines, they are more successful than we are. So somehow we have to find a way also to promote our project, which is very multidisciplinary in a difficult environment. For the future, again, I believe that capacity building is one of the main priorities for CEIST. And this is why I think that we should insist to go in the direction of coordination and support actions with a strong innovation content. But this is the kind of projects where we can also contribute. Instead, really a message that I have to pass is that at the moment we don't have the resources to embark into a new research and innovation action like E3+. Really, we don't have the people to do a new project like E3+. So we can think to a new strong technical project at the end of E3+, which is going to come in about 3 years or towards the end, so in a couple of years. But at the moment, this is really not so something that we cannot do. And also we had some discussions in a committee where I am a member that coordinates submissions of EU proposals for accelerators. And also here the recommendation is to decouple somehow the technical development that should be done, it should be Europe-wide and focused on accelerator technologies, to decouple the technological development from the support and the capacity building that is specific for CEIST. And this, I think, is the way for new European projects to go to coordination and support actions. And somehow maybe to revive the two proposals that we already made in the last months. Okay, now I'm coming to the conclusion of my presentation, and when I was looking at how I can finish my presentation today, I was looking at the slides that I made for the Budva meeting in September 19, was 2.5 years ago, and I've seen that basically the conclusions are the same. So I decided to recycle and do the same conclusions. And really, to stress, on the first this slide, I was stressing that the role of CERN and of other European institutions is to help in building capacity. This, I think, should be our main goal, and this is really to help you to develop an ecosystem that can support CEIST construction and contribute in the region, the competencies. So this accelerator you see is 250 million euros project. So it's a big beast, it's a big accelerator, it's a big center where you need quite a lot of competent people. It's true that they don't have many in the region, as Professor Litov said, but you have to grow them in the region. And I think that the intellectual qualities are there, the good people is there. The point is that they have to start working with us and learning, and they will be the one who will build and finally operate the facility. So the message, I believe, is still valid. At the time, we were thinking to submit a design study, HITRI, that was not successful because, among the other reasons, was somehow considered too political by the European Commission. So this is why we went to HITRI Plus, that is a more technical and wide project that was successful. We have to, at the time we were foreseeing, you see, in April 2020, a CEIST Meet Industry meeting. This we could not do because of COVID, and unfortunately COVID stopped all this process of approaching local industry. And this, I think, is something that we have to restart. So we are ready to help to support in this way, but we have also to involve local industry. And there are competencies, I mean, there are small industries that could really already from the beginning get somehow involved and participate in this activity, maybe with the help of European projects, because European projects are very happy when you can involve local industry. And then my last slide is that, okay, again, capacity building is the key point. I'm glad that all the next presentations today I've seen are on capacity building, so this is the key point to address. And at the time, what I say is that what is important, that we don't go to the region, we plant a tree that has been just prepared before in the Western Europe. We have to grow a tree, because only in this way the tree will be stronger, will stay there forever. And this, I think, is one of the important points that we have now to work at, is capacity building. And on this, I thank you for your attention.
Thank you. So now I can speak, okay, without echo. Thank you very much, Maurizio, and especially thank you very much for the advices which we gave to us, and we will take into account them, definitely. So, questions to Maurizio? I don't see any.
Yes.
Ah,
Yes,
sorry. Okay, please, go first.
Was a very informative, excellent talk. Thank you so much. I have a very critical question regarding the advances you mentioned about superconducting components. Can you give us a figure how much this will decrease the costs in building a facility, if? Because it certainly can be smaller, more compact, but the fact that you are using superconductivity increases your basic infrastructure, your basic investment. Is that correct or not? No?
No. The point why we explore superconductivity is because it is less expensive. The accelerator itself is about 20% less expensive, and then on top of that, you save on civil engineering because of the size of the building. And this is really, it's an advantage for the construction
Certainly.
of the machine.
I'm just asking this because some years ago, superconductivity was not really the solution for decreasing the costs. And I mean, I just ask this because, please don't laugh, I was visiting recently a meeting on laser-driven neutron sources. They're supposed to be compact, but you know, the backyard to have the laser is really huge.
Yes.
That's why. No, it's very interesting, really.
No, and on top of that also, nowadays, I mean, at CERN we have 27 kilometers of superconducting magnets, and really we are very happy with them, not only for the cost, but also for the reliability. So nowadays, really, a superconducting system is very stable, very reliable, and also industry is making a big effort in making new simple systems, cryocoolers for production of superconductivity. And so this is done inside Heat3 Plus and inside another European project, this development, and we have involved 4 companies that are already working with us for the development of the magnets. And the goal is to develop new, smaller, curved superconducting magnets that can be used not only by ion therapy like CEAST, but also by research accelerators of new design. Yes,
we would be very happy if you could come to Vienna
and again, the demonstrators, the first magnets, prototypes should be ready in 3 years from now and under test. So,
thank you.
And just to add something, oh, thank you. And just to add probably it's much better.
Give you another microphone, probably.
No. Okay, it seems okay now. So just want to add something. In any case, you are going to build the infrastructure for the superconducting magnets, because we plan to have a gantry, and to build a carbon ion gantry, for example, definitely it should be superconducting one. So it's synchronized with the accelerator.
Yes, I have a question concerning the, you said that for capacity building in Southeastern Europe, only Greece is a member of CERN, as far as I understood, from the region. What is the main obstacle for not having a, let's say, deeper and larger cooperation with CERN? Is due to the politics of CERN, due to the membership fee, or?
Of the region, I think members of CERN are Greece and Bulgaria. Yes, those are officially members.
And also associated members are Slovenia and Croatia.
Serbia,
Yes,
And Serbia is
And
full
Serbia.
member.
Exactly. So, and all of them, they have an easy access to CERN, and on the other hand, with non-associate non-member states, we can make collaboration agreements that we are ready to do, as we did for CEAST. We have collaboration agreements with other countries. So for us, I mean, we are open, but we need really an access to a technical counterpart in the countries. And at the moment, it is working well with Greece because there is a good contact with the University of the Aristoteles University of Thessaloniki, and is working well with Bosnia and Herzegovina because we have a contact with the University of Sarajevo, and we are happy to work with other universities. So it's and other research centers that are willing to work with us in this direction.
And the politics of CERN is just the opposite. CERN is trying to attract practically all countries from the region to become either associated or full members of the organization. So it's...
Thank you, Leander. I also would like to thank Maurizio for the very interesting presentation. And I have just a point on the conclusion, Maurizio, because you said at the end that you come back to the same conclusion as in Budva, and it's true that capacity building is very important in the region, and that the idea is not to bring a tree there, but to let the tree grow there. So it's a very nice image. And you said also that HIFRI was not successful because it was too political. So I really didn't get this point, because 2 weeks ago we were at the European Commission also with Leander, and actually the message that we got from DGNIR is that this project is relevant for the region, and that we have to highlight also that politically it's a very important project, as it was said before, also for the brain drain and the brain gain. So I really didn't get this point. Maybe if you can explain better.
Thank you for this question, because it's a critical point, actually. So it all depends on the structure of the European Commission. I believe that also to me it's sometimes a kind of a mystery how the European Commission works. But our interlocutor for this kind of projects is the Unit on Research Infrastructures. So we are presenting the CEAST as a research infrastructure first, not something to treat patients. So this is the key point. And they have a well-defined pipeline for supporting new research infrastructures in Europe that somehow doesn't fit very well with the CEAST, that is in between medicine and physics, and that is very, they show that they don't want to have too much political pressure while following this pipeline. And so this is one of the comments that I have received from the people of the research infrastructure at the time, is that the first submission of HITRI was too politically oriented for support to the region, and so was not well evaluated technically. Yes, but then this was by the head of the unit that was there 2 years ago, and now they've changed twice since that person, so I don't know what is the situation now.
There is a question from Boardroom.
It is on Zoom, from Zoom, yes.
Can I speak? Can you hear me?
Yes.
Okay, thank you very much, and sorry not to be with you. I have a question to Maurizio. You spoke, I think, about consumption, power consumption. I think that will be crucial for any new project. But we spoke about kilowatt. I think we have to speak about kilowatt hours. And it was a question linked to the previous one of superconductivity. I think if you have to evaluate the superconducting magnet, you have to evaluate also in terms of consumption. So to say, when you have a superconducting accelerator, you have to keep superconducting always. And we have a Ruban consumption. It will be interesting also to evaluate the consumption of superconducting magnets with normal magnets in terms of kilowatt per hours, and now to look at also for this project the type, what is the consumption and when we are doing the consumption, because it will be a crucial thing in the future. Thank you.
Thank you, Freddy.
Hello, Freddy. Nice to hear your voice from far away. Actually, this is what we did in our work. We compare the power consumption of normal conducting and superconducting magnets, and the conclusion is that it's about the same. So we were hoping to save the superconducting magnets, but what we have discovered is that the operation time of this type of machines is actually very low. Because if you count the time to switch between one patient and the other, preparation of patients, the actual time when the beam is in the machine is relatively low. While if you have a superconducting machine, you have to keep it cold all time. So, okay, but on the other hand, also the good news is that it is not worse either, the consumption of the superconducting magnets. But there is a nice study, and we are now preparing a paper on that.
Thank you, very good point.
Also, please.
Okay, this is not directly to Maurizio, but to all of the stakeholders that they can contribute to capacity building. There was a call once that we applied to, and we had that treasure application. The treasure was the acronym, and that was a good application, evaluated, very, very, very good, but not sufficiently to be funded. Yes, we have to find a call which is corresponding to this similar program that was at that time. So I haven't seen any, but we have to carefully watch and find a call which can absorb like 12 or 20 doctoral students to be educated by our leading scientists in the project and come back with a doctoral diploma and contribute to the region to develop this project. So let us go for looking for such a call, because these calls are more appropriate than twinning calls. Twinning calls are involving a limited number of countries, and we are entire region that has to be covered. And there should be a justice between the countries from the beginning, because we need to trust this project. So we have to choose students from every country on the Balkans and put them to Maurizio, to CNAO, to be educated and get their doctoral diplomas. So please try to build up a mentorship capacity in CERN and Sandro in CNAO to accept students as soon as we have a call, so we can apply and increase our human capacities for the region. So that was my point. Thank you.
Thank you. Any other comments, questions? I don't see. Thank you, Maurizio, once more.